I want to evaluate using special right triangles sine of 210 degrees. Here I have an xy plane, and I'm going to construct my angle in standard position. The initial side is on the positive x-axis, and the terminal side is going to be over here in quadrant 3, where the angle 210 degrees is. Now I want to find the reference angle. So I'm just 30 degrees past 180 degrees. So my reference angle for this example is 30 degrees. And I'm going to construct a triangle by dropping a perpendicular to the x-axis from the terminal side. I have a 30, 60, 90 right triangle. That means that I know the side lengths. The opposite side length of 30 degrees will be 1. Opposite 60 degrees will be the square root of 3. And the hypotenuse will be 2. However, this special right triangle is down in quadrant 3. In quadrant 3, to get to points in quadrant 3, I have to go left, meaning that this is going to be a negative radical 3. And I have to go down, meaning this is going to be a negative 1. Now I can go ahead and apply SOHCAHTOA and find sine of 210 degrees by using this reference triangle and recognizing that sine is opposite over hypotenuse. The opposite side is 1, the hypotenuse is 2. So sine of 210 degrees is negative 1 over 2. Now we'll evaluate cosine of 135 degrees. My angle in standard position starts on the positive x-axis. The terminal side will be in quadrant 2, where 135 degrees is, halfway between 90 degrees and 180 degrees. The reference angle this time is 45 degrees. So if I drop a perpendicular to the x-axis to create my reference triangle, I have a 45, 45, 90. Opposite 45 degrees has a side length of 1. So the other side is a side length of 1, and the hypotenuse is the square root of 2. I do have to take into account the fact that from the origin I'm traveling left, and so this side length is a negative quantity, but this side length here is a positive quantity since I'm traveling up, and the hypotenuse is always positive. Now if I want cosine, cosine is adjacent, negative 1, over the hypotenuse, radical 2. So we have negative 1 over the square root of 2. And if we rationalize, multiply top and bottom by rad 2, we have negative rad 2 over 2. Now for tangent 300 degrees. My angle of 300 degrees is going to be in quadrant 4, so just past 270 degrees, which is the negative y-axis. So the reference angle on this one, to get to the x-axis, that acute angle here is going to be 60 degrees. And so my reference triangle, if I go ahead and have a perpendicular to the x-axis there, it's going to be a 30, 60, 90 right triangle. So opposite 30 degrees again is a side length of 1. Opposite 60 degrees is a side length of the square root of 3, and the hypotenuse is 2. In terms of signs, positive or negative, this side here is going to stay positive since I'm traveling to the right, but because I'm traveling down, the y value is going to have to be negative. Now I'm interested in tangent of 300. Well, I'm going to use this reference triangle and do tangent, which is opposite. So opposite 60 degrees is radical 3, and then over adjacent. So the adjacent side here is 1. So tangent of 300 degrees is negative rad 3 over 1, or negative the square root of 3.